Hey, what's going on, everyone? It's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we will review logarithms. Many natural phenomena vary as a power function, a sub x, so that they display exponential change or growth over widely measurable ranges of the exponent x. We as engineers are therefore interested in the value of this exponent x, which is called the logarithm. Often when we are analyzing power functions in the form y is equal to a to the x, it is the y that is the known value, and the exponent x is the value that we wish to determine. So in order to determine x, we must rearrange the equations so that it is in the form x is equal to fy, which turns out to be the inverse of a power function and is called the logarithm, written as x is equal to log a base a y, where y is known as the argument. When encountering logarithms, there are many rules that we can use to simplify the process of solving for the required information. So let's go through a couple of those rules. When we see the argument of a logarithm as a product of two numbers, say log base a of y times z, it can be rewritten as the sum of the two logarithms, such as log base a of y times z is also equal to log base a of y plus log base a of z. Now, for example, say we're given a problem of log 6 3 times 2. This can also be written as log base 6 times 3 plus log base 6 2. Now, when an argument of a logarithm is a quotient of two numbers, say log base a of y divided by z, this can be rewritten as the difference of the two logarithms, such as log base a w minus log base a z. And so we could use the same numbers as we did before. Say we're given log base 6 of 3 divided by 2. This can also be equal to or is equivalent to log base 6 3 minus log base 6 2. So what about when an argument of a logarithm is a power of two numbers, say log base a times b to the y? Well, this can be rewritten as the difference of the multiple of the logarithm, such as log base a b to the y is also equal to y log base a b. Now we can illustrate this by looking at log base 6 3 to the 5th. Writing this out, we got log base 6 times 3 times 3 times 3 times 3 times 3, 5 times. And this, if we go over to here, plays out to log 6 3 plus log 6 3 plus on and on for 5 terms. So all we need to do is know that this is a common term repeated 5 times, so we just pull 5, which in this case would be the y, out in front of the log, and it's equivalent. So we got y log a to the b, or 5 log a with 3. So now that because any number raised to the power of 1 is equal to itself, if you recall, a raised to the 1 is equal to a, then the following logarithmic identity always holds true. Log to base a of a is equal to 1. On the other hand, because any number raised to the power of 0 is equal to 1, so a to the 0 is equal to 1. We know that from our power function tutorial. The following logarithmic identity is always true. Log base a 1 is equal to 0. Now, in all mathematical studies, the base 10 logarithm is very important and is called the common logarithm, and typically the subscript after the log is dropped. So to illustrate that, we typically see that, say we're given the logarithm x is equal to log base 10 of y. This is also rewritten as the common logarithm as simply as log y. Now, so if we see log by itself, it is naturally a base 10 problem. Now, another base that naturally shows up in math is the transcendental number e, which is equal to e is equal to 2.7182 blah blah blah, keeps going. And as we discussed in the power functions tutorial, the power of this base is equal to its own derivative. So we got, say we have the function e to the x, that derivative dy dx is also equal to e to the x. So when e is the base of a logarithm, it is better known as the natural logarithm, typically abbreviated ln. So to illustrate this, say we're given the logarithm x is equal to log e y. This can be rewritten as the natural log of y. So graphically, we typically see logarithms take the form something like that, and that's just general. So visually speaking, we can see now why logarithm functions are used when we discuss slow growth measurements. So that's it, guys. That's logarithms, a quick review of the rules of logarithms and just how to work with them. If you guys have any questions, head on over to engineeringandtrainingexam.com. Shoot me a contact, give me some feedback either here on the YouTube channel or over there over private email. I answer all the emails that I get because my aim is to help you guys out in any way that I'm able. So I hope I'm doing that. I'm providing value. If you guys have any suggestions, don't hesitate to contact me. So we'll be talking soon, guys. You guys have a great day. All right? Take care. Bye.